Hi, this is Janakareddy Dubaka. Neet physics quick revision, that is formula revision. This is center of mass lecture 1 or part 1. See here, locate the position of center of mass in that system of two particles. See here, in a system, there are two particles, M1 and M2. These two are separated by distance d. For this system, see, this is the center of mass. Therefore, the distance of center of mass from the first particle, that is R1, and this one is R2. According to the properties of center of mass, the mass moment, sum of the mass moments about the center of mass 0. Therefore, here M1 R1 is equal to M2 R2. Therefore, here R1 by R2 is equal to M2 by M1. So, this is one important relation. See, if you want to find out the distance of center of mass from first particle, that is R1. So when you measuring the distance of center of mass from first particle, here second particle mass by total mass into total distance. Here is R1. Similarly, R2, that is distance of center of mass from second body, that is first body mass by total mass into total distance. For example, here if two bodies having equal mass, if M1 is equal to M2 is equal to M, then R1 is equal to R2 is equal to D by 2. Therefore, for equal masses, center of mass is at the center of the line joining the two particles. This is a system of two particles. Another one, center of mass of system of discrete particles. See, discrete particles mean there are large number of particles. For example, here is a particle 1, mass M1, its position vector is R1. Like that, M2, its position vector is R2. Like that, this is M1, its position vector is R1 bar. Therefore, the position vector of center of mass RCM bar is equal to M1 R1 bar plus M2 R2 bar, so on, plus Mn Rn bar by M1 plus M2 and so on Mn. This is the formula for the position vector of center of mass of a discrete particle system. See here R1 bar is equal to x1 I cap plus y1 j cap z1 k cap. Like that, Rn bar is equal to xn I cap plus yn j cap plus zn k cap. This RC bar we can write down XC I cap plus YC j cap plus ZC k cap, where XC is equal to M1 X1 plus M2 X2 so on Mn Xn by M1 plus M2 so on Mn. Like that, YC is equal to M1 Y1 plus M2 Y2 so on Mn Yn by M1 plus M2 so on Mn. Next, ZC is equal to M1 Z1 plus M2 Z2 so on Mn Zn by M1 plus M2 so on Mn. These are the coordinates of center of mass along x, y, z coordinates. This is a center of mass of a discrete particle system. See, For example, here is one problem. If the problem is given like this, here 1 kg, this is 1.5 kg, and this one is 2.5 kg, and this side is 4 centimeter, this is 3 centimeter, here is a 5 centimeter. We have to find out the coordinates of center of mass of the system. See, in step 1, we have to first locate the coordinates of each mass. For example, this is, it is at origin, therefore 0 comma 0, and here is 3 comma 0, this one is 0 comma 4, means x1 comma y1 is equal to 0 comma 0, x2 comma y2 is equal to 3 comma 0, and x3 comma y3, that is 0 comma 4. These are the coordinates of the masses. Then xc is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Therefore, xc is equal to mass m1 is 1 kg, 1 into 0. M2 is 1.5 into 3. M3 is 2.5 into 0 by total mass 1 plus 1.5 plus 2.5. Finally, we can get this is 0.9 centimeter. Like that, Yc is equal to M1 Y1 plus M2 Y2 and so on, plus M3Y3 by M1 plus M2 plus M3. After substitution, we can get 2 centimeter. Therefore, xc comma yc is equal to 0.9 comma 2 centimeters. These are the coordinates of center of mass. Like that, another problem. Here, three particles of masses 50 grams, 100 grams and 150 grams are placed at the vertices of equilateral triangle of side 1 meter as shown in the figure. The xy coordinates of center of mass. Here also, first for the particle 50 grams, coordinates x1 comma y1. See, x1 comma y1, that is equal to 0 comma 0, and x2 comma y2. See, for this particle, it is a distance of 0. Side is 1 meter. Therefore, here 1 comma 0. Then x3 comma y3. See, this is the particle is in xy plane. Draw one perpendicular onto x-axis and one perpendicular onto y-axis. This distance, it is equally divided. Therefore, this becomes 0.5. Therefore, x coordinate is 0.5. Then I have to find out the y coordinate, means this distance. In this triangle, we can find out, or see, here it is 1 meter. Therefore, if you resolve this one in this direction, 1 cos 60, but whereas in this direction, 1 sin 60. Therefore, 1 into sin 60 root 3 by 2. Therefore, this is root 3 by 2. These are the coordinates. Then, xc is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. See, by substituting the values, we can get 7 by 12. Like that, yc also m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Here we can get root 3 by 4. Like that, we can find out the coordinates of center of mass of in a discrete particle system. See, here is another problem. Here, two particles of masses 4 kg, another one is 2 kg are located as shown in the figure. Then find out the position of center of mass. See, here the 4 kg mass is at the origin, therefore its coordinates x1 comma y1 is equal to 0 comma 0. Then here 2 kg, its coordinates, if you draw the two perpendiculars, one onto x-axis, another one is y-axis. This distance is nothing but 5 cos 37. and this distance is 5 sine 37. Therefore, x2 comma y2, first we have to find out x2. See, x2 is equal to 5 cos 37. See, whenever you are familiar with angles 30 degrees, 45 degrees, 60 degrees, 90 degrees, but we are not familiar with 53 degrees, 37 degrees. See, 57 degrees is given like this. You have to write 3 year, 5 year, and 4 year. Therefore, year 3, here is 5, here is 4. And this one is 37 degrees. Therefore, cos 37. From this triangle, cos 37, adjacent side by I put it, that is 4 by 5. Therefore, 5 into 4 by 5. Therefore, 5 gets cancelled. X2 is equal to 4. Like that, y2 is equal to 5 sine 37. Therefore, y2 is equal to 5 sine 37, 3 by 5. This is 3. Then xc is equal to m1 x1 plus m2 x2 by m1 plus m2. Therefore, we can get the answer xc is equal to 4 by 3. Like that, yc is equal to m1 y1 plus m2 y2 by m1 plus m2. Here after substitution we can get answer 1. This is the method to find the coordinates of center of mass of discrete particle system. Another important thing, shift in center of mass. Since shift in center of mass, we have to know some geometry. See, for example, this is the equilateral triangle and this is centroid. For example, here is A, this is M. From vertex to centroid, the total, for example, this equilateral triangle of side L. Therefore, this distance is L by root 3 and this one also L by root 3 and this one also L by root 3. This is centroid, I am taking O or otherwise C. This is centroid C. Therefore, CM, this distance, here it is 30 degrees. Therefore, this one is nothing but L by root 3 cos 30 and this one is L by root 3 sin 30. Therefore, L by root 3 sin 30 means 1 by 2. Therefore, L by 2 root 3 means from centroid to any side, this one also L by 2 root 3 and this one also L by root 3. Then total height of the triangle AM, that AM is equal to, this is the total length L and this is the angle 60. Therefore, this becomes this distance is L cos 60 and this one is L sin 60. AM is equal to L sin 60. This becomes root 3 L by 2. This is geometry you have to know. Any equilateral triangle from centroid to vertex L by root 3. This is also L by root 3. This is also L by root 3. From centroid to any side, that is equal to L by 2 root 3. And here height of the triangle, total height AM, that is equal to root 3 L by 2. Like that, if you take a square of side L, see here is the intersection points of the diagonal. From this point to vertex, this is L by root 2. This one also L by root 2. This one also L by root 2. This one also L by root 2. And this is L by 2. See, with this geometry, for any problem given, for example, shift in center of mass, we can find out the shift in center of mass. See, for example, this is the equilateral triangle. Therefore, three masses are placed at the three vertices of equilateral triangle of side L. Therefore, its center of mass is at the centroid. This is I am taking C1. If I removed one mass from the three masses, then what is the shift in center of mass? See, See, here the mass is removed from this vertex. Now, in the system, center of mass is this system having only two masses. Initially, center of mass is at C1. Now, in the system, there are two masses. Here is M, here is M. These are the two masses and the two equal. Therefore, their center of mass is at the center. This is C2. Therefore, initially center of mass is at C1. Now it is shifted to C2. This is nothing but X. Shift. Shift is equal to X. Therefore, X is equal to, in the geometry, what is this length? Centroid to any side, that is root 3 L by 2. Therefore, this becomes root 3 L by, sorry, not root 3 L by 2, L by 2 root 3. Sorry. This distance is here C2M, that is L by 2 root 3. Therefore, shift is L by 2 root 3. Like that. Example 2. M, M, M. Therefore, center of mass is the centroid, C1. If any one of the mass is doubled, for example, any mass, this is doubled. Now this becomes this is M, this is M, this is M, and plus M. Therefore, these three masses initially at the centroid, that is C1. Therefore, total mass is 3M. Now this is another mass M. Now the system like this. See here, this is the mass 3M and this one is M. Initially center of mass is here. Now by placing this mass, center of mass is shifted from C1 to C2. This is X. See, here from first mass or this mass 3M, the shifted center of mass distance X. Now this is C2, this distance is X2, and between 3M and M, the total distance is L by root 3. Now I have to find out shift, that is X. Therefore, center of mass distance from first body means second body mass by total mass. Second body mass is M. Total mass 3M plus M, 4M. Then total distance is L by root 3. Now, here M cancel. Therefore, shift X is equal to L by 4 root 3. Like this. Another example. This is the square of side L. 4 masses placed at the 4 vertices. Then center of mass is at C1. Now one of the mass is doubled. Then center of mass shifted from C1 to C2. This is X. Here see M, 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 M. I doubled one mass. See here, these 4 masses, total center of mass initially at C1, that is 4M. Now another mass is added. Therefore, center of mass is shifted from C1 to C2, X. Now in the system, there are only two masses. One is 4M and M. It is like a two particle system. 4M and M. Total distance is L by root 2 from center to this distance. This is L by root 2. Therefore, this is L by root 2. Now center of mass is shifted to C2. This is the X. That shift in center of mass from first body means second body mass M by total mass M, 4M plus M, 5M, and total distance is L by root 2. Therefore, M cancel. That is L by 5 root 2. This is a shift in center of mass. See, in some problems, there is a Planck's problems. So here, this is the tabletop. On this tabletop, we arrange planks of equal dimension and same mass. This plank is projected from this edge of the table x, and this one also x, this one also x. All planks are projected equal distance from the edge of the table. Then for system of equilibrium, that what is this projected length? Here x is equal to formula, x is equal to L by n plus 1. Here n is nothing but number of tapling planks. Therefore, this is the tabletop. The chance of tapling is 1, 2, 3. Therefore, here x is equal to L by n is 3, 3 plus 1. Therefore, L by 4. For example, here this is the plank 1 arranged on the ground, and planks are arranged like this. But these projections are different now. Here we have to count from top of the plank. This projection must be L by 2. This is L by 4. This is L by 6. If there are n planks, xn is equal to L by 2n. xl is equal to L by 2n, where n is number of the plank from the top. For example, if you take 1, 2. If you take 2, 2 into 2, 4. Third one, 3 into 2, 6. Therefore, xn is equal to L by xn is equal to L by 2n. Like this, for this one, therefore, the projection of the first plank is L by 2, and the second plank is L by 4, and the third plank is L by 6. Like that, total system is in equilibrium. In some problems, we may ask what is the total distance from this end. Therefore, L by 2 plus L by 4 plus L by 6. This is part 1, center of mass. Then another lecture, that is part 2, coming soon.